Once we get these last two parts done, then we're through with section 1.6. All right, first thing. Please write this down. So what's it saying? It's saying if you've got a fractional exponent here, like that 2/5, the top number is the power you're going to raise this base, x in this case, you're going to raise that base to. The bottom number is the root that you're going to take that to. So this says either, you look at this one right here, it says either take the square root of x squared, take the fifth root of x squared. So you're squaring the x first and then taking the fifth root. Or, like out there on the end, you're going to take the fifth root of x and then square it. Those are all three equivalent. Y'all remember that from Algebra 2 or pre-cal? Okay, that's reminder number 1. Here's reminder number 2. And this goes all the way back to your Algebra 1 days, back in your reckless youth. And it's saying if you've got a base raised to a power like x squared, and then you take all of that and you raise that to a power, in this case, cubing it, well, to get the result, you just multiply these two exponents. The 2 times the 3, and you get x to the 6th. You don't add them, you multiply them. Brings us to here. And this little concept right here we're going to be using in just a few seconds, really. So these 3 dots mean therefore, if I've got x to the 2/3 power, and I'm raising all of that to the 3/2 power, it's just x. How come? They do. Thank you. They cancel. That's going to come in handy to solve the kinds of problems that we're fixing to solve. Okay, question about that at all? On this beautiful rainy day. Then let's solve some problems. Here's example 1. So what I'm going to do is put all of this in parentheses and say I want to raise that to the 5/2 power. In other words, the reciprocal of the exponent that's there now. And if I do that to one side, I've got to do it to the other side. Well, we know this left-hand side is going to cancel out and just leave me x. Now, here's the thing on the right-hand side. It's usually easier to do the bottom number first, in this case, that 2 right there. So this says take the square root of 4 and then raise that to the 5th power. It's usually easier to do the bottom number first. Well, what's the square root of 4? 2. And so that's saying, basically, 2 to the 5th. What's 2 to the 5th? 2 times 2 times 2 times 2 times 2. Morning. So 32? And then we check it. So I go back to my original equation and I say 32 to the 2/5 power. Does that equal 4? So again, I'll take the bottom number first, that root, and say, well, what's the 5th root of 32?
2.
Thank you. And then I'm raising that to the 2nd power. Does that equal 4? Yeah. There's our answer. Now, without that little exponent trick, that might be kind of bad to solve. Anybody have a question about that one? We have a short class time today, so I'm not trying to rush you. I just want to make sure we talk about what we need to talk about. Here's another one. Y'all try this one. Okay, so what do I do first? Got a volunteer? Katie, thanks. I didn't think we were going to have one there.
Multiply by 2 over 3.
All right, so I'm going to do this. If I do it to that side, I got to do it to this side. Thank you, ma'am. And so on this left-hand side, those are going to cancel. Just leave me x. On the right-hand side, again, take the bottom number first. What's the cube root of 125?
5.
5, thank you. Now, is it plus or minus? Elijah's saying no. Why not? Or why? It's odd. The power's odd. See, back here, we had an even power on the bottom. So we had to do the plus or minus thing, which I didn't do. Y'all let me get by with that. Let's work the one that we're on, and we'll come back to this one. All right, so this one, though, is an odd power on the bottom, so it's just plain old 5 raised to the 2nd power, which is 25. And we can check that, and we can go back and say, again, not plus or minus. We can say 25 to the 3/2 power. Does that is a 2 there. Does that equal 125? So we take the square root of 25, which is 5, to the 3rd power. So yeah, there's our answer. Let's go back. This should be the square root of 4 is plus or minus 2. So this should be plus or minus 2 to the 5th. So one version of that is negative 2 to the 5th, which is what? Negative 32. The other version is the one we originally got. So let's check this thing. Will negative 32 work? Does that equal 4? So we know this one worked right here, the positive 32, because we checked it. But we didn't check this one. So what's the 5th root of negative 32? 2, but is it positive or negative? Negative, 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 negative. So negative 2 squared. Does that equal 4? Yep. So we have 2 solutions to that one. All right, and then we got this one. And then we got this one. A little bit of a twist to it. Bless you. Let's see if our same trick works. So I'm going to put brackets around this and say raise this to the 3/2. Raise this to the 3/2. Well, my exponents cancel over here, which just leaves me x minus 4. All right, I'm looking on the right-hand side. If I'm going too fast, say something. So I take the square root of 16, which makes, what, plus or minus 4, cubed. On this side, I've got x minus 4. So I bring the 4 across. I've got x equals 4 plus or minus 4 to the... Well, that's a bad way to write it. There we go. All right, so the first version, x equals 4... What's minus the cube root? I'm sorry, what's minus 4 cubed? 4 cubed is 64, but so we've got negative 4 times negative 4 times negative 4. So negative 64, so this is going to be 4 minus 64 equals minus 60. That's one possible solution. And then the other one is x equals 4 plus 64. So we've got two possibilities there. Check the first one, negative 60. So I've got negative 60 minus 4 to the 2/3. Does that equal 16? So I'll take the cube root of negative 64, which is negative 4, thank you. And I'm going to square it. Does that equal 16? Yeah. So first one is good. Do the same thing. I've got 68 minus 4 to the 2/3. Does that equal 16? So this is 64 to the 2/3. Take the cube root of 64, that's 4. Square it. Yeah. So we've got two solutions to that one. Questions, y'all? Okay. If you all will try this one, we'll see how it turns out. What do I do first, please? All right, so I'm going to make that raised to the 5/2 power on both sides. Thank you, sir. And that means over here, I just get x plus 7. And over here, on the right, I'm going to take the square root of 4. And I'm going to raise that to the 5th power. So again, we're going to have two possible solutions. So I've got x equals minus 7. Let's say for our first one, plus minus 2 to the 5th. And negative 2 to the 5th is negative 32. So there's one of our possibilities. Our other one, we're going to say x equals minus 7 plus 2 to the 5th there are possibilities. And we could go through and check those, but since we have a short class time, I really want to get to the next stuff. So all that's left to do on that one is checking it. Everybody ready? Okay, if you'll jot this down, please. Okay, here are a couple of things about this quadratic equation. It's quadratic because why? We've got x to the second power. But something you might not have thought about before is that second power is twice as big as the power that x is in the middle here. So that x in the middle term has a power of 1. And another thing I just want to point out is that 2 is even. I know y'all know that. But we're looking for something that has an even power for our highest exponent that's twice as big as the power in the middle. And this certainly fits that. It's a pattern, like a whole lot of math is. Let's see how that's going to help us. Now we can use the AC method on this one. Do we need to? Anybody just look at that and tell me what the factors are?
X plus 2 and x minus 1.
Nearly.
X plus 2, x plus 3.
All right, x plus 2, x plus 1. If you wanted to use the AC method, you could. Those are the factors it would give you. So I solve. So I'm getting minus 2 and minus 1. Easy. Everybody okay with that? Let's do another. That was just a plain old quadratic equation. How about this one? I'm looking for a form. Is my highest exponent even? Yes, it is. Hurdle number 1. Is it twice as big as the middle exponent? Yes, it is. So that means this is quadratic form. Now, it's not a quadratic equation, but it's got the form of one. So here's what I have to do. I have to visualize this as, look at our middle term here. This is 3 times x to the 4th. But look at our first term. Isn't it just x to the 4th squared? Isn't it just this? Now take a look. This 2 right here, the exponent right here, and then this one has an exponent of 1, understood. That's quadratic. That is a quadratic equation, if you look at it like that, which means I can solve that thing. But what I'm going to do is make a substitution. I can always substitute an equal for an equal. So I'm going to say, y'all pick a letter. The book is going to use U. What do y'all want to use? M. Okay. So I'm going to say M. That sounds like pre-cal, doesn't it? I'm going to say M equals x to the fourth. So every place I see an x to the fourth there, I'm just going to put an M. So that changes this to m squared plus 3m plus 2 equals 0. Have we seen that before? Yeah, we just solved it. Right there. Same form. So I know that this is going to turn out to be m plus 2, m plus 1 equals 0. And I know that m is going to equal negative 2. And I know that m, at least potentially, and so here are my two potential solutions, but that's for m. I want x. So what I'm going to do is come over here and say, okay, I got m equals negative 2. That's my first possible solution. I'm going to put negative 2 here for m. That equals x to the fourth. I'm just plugging the 2 in there, the negative 2. Now what? I got to take the fourth root of both sides. So the fourth root of negative 2 equals the fourth root of x to the fourth. So I've got x equals this thing. What does that tell me? It's going to be imaginary. That just didn't look right to me, the period 1. I sat there and looked at it. But it is. If you stop and think about it, look at our original equation. I've got x to the 8th. Is there any way that could turn out to be negative? No matter what value of x, it can't be negative. Look at x to the 4th. Is there any way that that could be negative? Now I've got plus 2. So no matter what values of x I put in there, the y for that is always going to be positive. Never touches the x-axis, never crosses the x-axis. Okay, so I've got one imaginary solution, and I go back and I put in negative 1 here. And what am I going to get? I'm going to get x equals the fourth root of negative 1, just like I did with the negative 2. So I've got two imaginary solutions. So this one, even though it was quadratic in form, has no solutions. Look back at example 5. The true quadratic one ended up having 2. This one, not so much. But the way we got to there was to put it in quadratic form, using that substitution trick. All right, let's take a look at another one. Holy cow. So I'm looking at that middle term, and it's negative 7 times x squared, but I'm really interested in the x value. So I'm going to say m just equals x squared. And this is really 2 times x squared minus 7 times x squared plus 5. Just rewriting it. So when I substitute m in there, I'm going to get 2m squared minus 7m plus 5 equals 0. So we can try AC method. So 2 times 5 is 10. When I add them together, I get negative 7. What two numbers, when I multiply them, I get positive 10. When I add them, I get negative 7. Oh, thank you. So I'm going to say 2m squared negative 2m negative 5m plus 5 equals 0. So I can pull a 2m out. I can pull negative 5 out. And start combining things here. So I've got 2m minus 5 times m minus 1. Pause there for a second, see if I'm okay. All right, so now I say 2m minus 5 equals 0. 2m equals 5. M equals 5 halves. I say m minus 1 equals 0. M equals 1. Those are our potential solutions, but that's for m. So now I have to come back over here and say, all right, I've got to go back and substitute my values that I got for m in relationship to x squared. So I'll take my first one, 5 halves equals x squared. So now what? I can say raise this to the 1/2 power. Oh, there's probably a better way of writing it. I can just say take the square root of both sides. So I've got the square root of, so plus or minus, equals x. All right, there's one possible solution that we could check, and there's two possible solutions that we could check, right? Positive version, negative version, and then I'm going to say 1, this value, equals x squared. So x equals plus or minus 1. So I've got 4 potential solutions here. Plus or minus the square root of 5 halves, plus or minus 1. And I'd have to go back and check each of those. But I've got 4 of them there. Which kind of makes sense. I'm looking at that 4 exponent. That means I've got at most 4 solutions. All right, here's one that you're going to have. These last two are kind of like you're going to have in homework, but this one definitely is. Does this work with negative exponents? I'm looking at this middle term here, x to the minus 1 power. That's what I'm going to let m equal. This looks weird. So this is really 10 times x to the minus 1 squared plus 33 x to the minus 1 minus 7 equals 0. So every place I see an x to the minus 1 power, I'm going to put m. So I've got 10m squared plus 33m minus 7. And now we've just got a quadratic. Oh, by the way, is the first power there, that minus 2, is that even? Yeah. Is it twice as big as in absolute form anyway, twice as big as that middle exponent? Yeah. So we can do this. So negative 70 when I multiply 8 times c, and I get 33 when I add them. Two numbers, I multiply them together and get negative 70. I add them and I get 33. Good. Thank you, sir. So I've got 10m squared minus 2m plus 35m minus 7. So I can pull 2m out. And I can pull out 7, can't I? So I'm getting 2m plus 7 times 5m minus 1. Solve each one of those for m. There's our solutions for m. But now I got to go back and plug those values into this thing right here. So I got negative 7/2 equals x to the minus 1 power. Now y'all, x to the minus 1 just equals 1 over x, right? So if I want to solve that, an easy way to do it is just to flip both sides. So negative 2/7 equals x. Because x to the minus 1 equals this. If I just flip both sides, here's one answer that we would need to check. I'll do the same thing. 1/5 equals x to the minus 1. I flip both sides. Here's my other potential solution. Did that mess anybody up? I'm just getting the reciprocal of both sides. You will see something like that in the homework. You'll see something like all of those in the homework. But I looked at the homework and something just like this is going to pop up. Tomorrow, y'all.